All right, so you haven't learned anything about slope in physics. Haven't you been graphing lines in physics? Okay, so what did you learn about them? What did they say in class at all? Okay, what's the equation? Okay, so that's slope-intercept form. They haven't told you what slope means at all? Rise over run is what it is. M, okay, but you didn't know what it means. Because in physics, that's the application of your slope. All right, so write this down because I will ask you this question. Notes are back there, pick one up on the desk. So slope is the rate of change of y to x. So you already said that you knew that slope was rise over run, correct? Doesn't y go up and down? Isn't that your rise? And doesn't x go right to left? Isn't that your run? This is the official meaning of slope. It's your rate of change. And in physics, didn't you look at slope as a rate of change? Like a speed, right? Or acceleration, that type of thing. So we're going to actually do all of that here. So if you graph lines in physics, hopefully this should be easier for you today. All right, so slope is, and a lot of what you said is true. Did they use this symbol in your physics class? What's this triangle mean? Change. So that's your change in y over your change in x. And you already said that we have rise over run. So that's another way of saying what slope is. What is the actual formula? Nope, that's your slope-intercept form. Okay. So y sub 2 minus y sub 1 over x sub 2 minus x sub 1. And that's given two different ordered pairs. So if those are your two ordered pairs, this is the actual formula. And then some of you also mentioned that this formula is equal to m, the letter m. Why m and not s? Do you know why that is? What does s mean in your physics class? Seconds. What else could it mean? Speed, right? So notes are in the back. Please pick one up and quietly sit down and get busy. All right, so example 1. We're going to find the slope of the line that passes through the point. So not only do you have a graph, but you also have the ordered pairs. So you could do one of two things. You could either use the algebra formula, y sub 2 minus y sub 1 over x sub 2 minus x sub 1, because you got the ordered pairs, right? But anytime I've given a graph, I'm going to find my rise and my run. It'd be a lot easier to find your rise and your run, but you have to pay attention to the direction. So look here, if these are my 2 points from here to here, wouldn't this represent my rise? How far is my rise? 2 units. When I go from this direction down, so I'm going down, give it to Chris. Is that a positive direction or a negative direction? Negative. So this represents a -2 direction. Wouldn't this be my run? Okay, so your x direction is your run. If I'm going to the left, is that a positive direction or a negative direction? Negative. So how far did I go left? So this is a -5. So my slope, my rise is -2, my run is -5. Is that how I would write my final slope answer? What do you know about the two negatives? They cancel each other out. So you better write your final slope as +2/5. Looking at a line, you ought to be able to tell whether the line is positive or negative just to begin with. Look at the tip of your line right there. It's either going to point into quadrant 1 or quadrant 2. Quadrant 1, do you remember the sign of quadrant 1? Positive, because it's surrounded by positive times positive. So this is your positive quadrant. And what's the sign of quadrant 2? Negative, because what is it bordered by? Negative times a positive. Doesn't that give you a negative? So if your line is pointing towards the positive quadrant, it's saying, hey, look, I'm positive. So you ought to know before you even find your slope whether you should be coming up with a positive or negative slope. Could you ignore your direction signs then? Sure. If you absolutely positively have that down, you wouldn't have had to put a -2 over -5. Now, I could have, this is called a stair step, I could have stair stepped above my line, couldn't I? If I went up 2 to get to this point, that's a positive, right? And then I would have had to go to the right 5, that's a positive direction. So you could have had a +2 rise over a +5 rise, which is still going to give you a 2/5. So it doesn't matter whether you stair step above the line or below the line. You should still get the same answer. So try part B on your own. Make a stair step from point to point. What's the overall direction of this line? The notes are in the back of the room on it. Yes. Is this a positively sloped line or a negatively? So you should know from the get-go that your answer is going to be negative. Because there's the tip of that line that's pointing towards the second quadrant. So when I ask you for a slope, don't write it necessarily as a fraction. Because this slope would have been -2 over 1 or 2 over -1, bless you. We only use that when we're actually stair-stepping the slope and plotting the line. So if I ask you what's the slope of the line and you tell me that it's -2 over 1, you'll lose some points because it's really just -2. So if 1 is in the denominator, don't write the 1 as a denominator. All right, so how'd you do with that? You okay with that? All right, so let's look at C. C has no graph to it, right? Well, it's still fuzzy. So if I don't have a graph, I have a couple of options. Well, let's try it one more click. There we go. Bless you. If I don't have a graph, I could plot those points. But look at D. Do you want to plot those points? No, that's starting to get really big. So at some point, you have to learn how to use your algebraic equation. So for these two, I want you to use, you can go ahead and write it here. M equals y sub 2 minus y sub 1 over x sub 2 minus x sub 1. So that's the algebraic formula we're going to use for slope. So try it on the first one. I want to see you labeling each of the points x sub 1, y sub 1, x sub 2, y sub 2. And then this is just going to be my blueprint. It's telling me what I do with it. So if I were you, I would write out the formula, because it is a formula, and I would put the negatives in there. Because the biggest error that you're going to make on this is having the wrong signs. So if you put the negatives in there to begin with and then plug in your numbers, you shouldn't have as many sign errors. So then plug in your y sub 2 comes first, which is 10. Y sub 1 is 2. X sub 2 is 6. And x sub 1 is 4. And by the way, would it have mattered if I had made this x sub 2, y sub 2, and this x sub 1, y sub 1? Yeah. It won't make a difference. You can decide whichever point is point 1 or point 2. What's going to happen, if I have the 2 and the 10 reversed and the 4 and the 6 reversed, I'm going to get a negative over a negative. What's a negative over a negative? So you'll still get the same answer if you line them up correctly. So notice that 10 and 6 belong to the same ordered pair, and 2 and 4 belong to the same ordered pair. Make sure that you have your y's up top and your x's on the bottom. Otherwise, you're going to have your slope will be an inverse. It'll be a wrong number. So what's 10 minus 2? 8. And 6 minus 4? 2. Does that reduce? Yeah. So your answer is 4. So if you had switched the ordered pairs, you would have had -8 over -2. That still reduces to +4. And you can always check your slope by plotting the points and just double checking if you wanted to. All right, so do D on your own. Label your points. And when I grade your work on this, I want to see you plugging into this formula. If I don't see you plugging into that formula, you will lose points. So don't do scratch scratch work. So what's your value up top? What do I do with 7 minus a negative 8? Yeah, and the biggest mistake that I see here, if you don't put the negatives in first, I end up seeing 7 minus 8. You see how that can be a problem? So make sure you put those negatives in first. So you should end up with a positive 15 up top. And then again, I don't want to subtract 13, I want to add a negative 13. So what's a negative 12 and a negative 13? Negative 25. Does that reduce? What goes into both of those? So 5 goes into 15 3 times. 5 goes into negative 25, negative 5 times. That negative, it can be in the bottom number, it can be in the top number, or it can be hanging out to the side. It doesn't matter which, it still makes it negative. So there's your slope. So there's your 2 ways to find slope, either by graphing, stair step, algebra, use the slope formula. All right, so then we're going to start graphing with something called direct variation. Direct variation is the easiest way to graph, and it's just described by an equation that's in the form of y equals kx. Now k, a lot of you mentioned that you knew y equals mx plus b, right? This means, this is just basically y equals mx. There's no plus b. If there's no plus b, what does that mean? It starts at the origin. Good. So this really, k is just another name for m. So k is going to represent the slope of this direct variation. And this is red, y varies directly as x. So this equation, y equals kx, is read, y varies directly as x. The minute you see those words, and you're going to have word problems here in a minute, the minute you see the words y varies directly as x, that entire phrase can be replaced with y equals something times x, and I'll teach you how to find that k. And as Savannah said, the graph of this equation always goes through the origin. So 100% of the graphs here are going to start at 0, 0. This k is also, although it's another name for m, this k right here is called the constant of variation. It's how y varies directly as x. Constant of variation is just another fancy name for the slope of that line. So this part down here, k, is the constant of variation. There it is again. And then this is just, you can put a colon here if you feel better. K is also the slope of the line. You get the idea that I want you to understand that k is the slope? I've pounded you over the head with it. All right, so in example 2, you're going to be asked to name the constant of variation. It's really simple, especially if the equation solved for y. And then you get to graph each equation. So let's look at A. What is the constant of variation? What is k equal to? 2. So to graph it, the very first thing you do is plot a point at the origin, which is 0, 0. So that's our very first step. So I'm going to plot a point at 0, 0. There's my starting point. You always 100% of the time have to start at that y-axis. So then the second thing that we're going to do is we are going to stair step, and that's a technical term, the slope using K, the constant of variation. So up here, if K is 2, we want to look at that as a fraction. So now that I'm going to stair step, I do want to look at 2 as a fraction. So K is my slope. My fraction for 2 is 2 over 1. That's my rise over my run, isn't it? True or false? Yep, this is my rise, and this is my run. I can also look at my slope in a different direction, because if I look at it as 2 over 1, if my rise is positive 2, is that up, down, right, or left? Up. So what this is saying is I need to go up 2, and then 1 is my run. Is that right or left? Right 1. So if I just plot it and I go up 2, don't plot a point, and then to the right 1, wouldn't my point be plotted there? And that's what that stair step looks like. Here's your up 2 and over 1. I could do this all day long. Up 2 over 1, plot a point. Up 2 over 1, plot a point. Now you don't have to have these little stairs in your homework. You're doing it for your note purposes. So this is your rise of 2, my run of 1. But I only really have half of my line. You really need to fill out the entire grid with however many points it takes to get there. Sometimes it's 3 points, sometimes it's 6 points. It just depends. So you need to get used to going in a different direction for your slope. Change both signs. Change both the top and the bottom. If I change the signs, don't I get negative 2 over negative 1? Doesn't that still equal positive 2? Yes or no? Yes. So now if I go down 2, well, negative 2, isn't that down 2 for my rise? Then what's my negative 1? Left 1. So if I go down 2 that far, then I have to go left 1, plot a point. Did I land on the same line? Yeah. So you've got to get used to going in 2 different directions, because oftentimes we need to be able to go in both directions. Whoops, missed it. There we go. And so then you absolutely positively, without a doubt, have to use a straight edge. So then connect your points. And you must put arrows on both ends of your line. If you don't, you'll lose some points, because you're not telling me that you know it goes infinitely in both directions. So step 3, connect your dots, or connect your points, and add arrows. All right, so you try B on your own. So run through these steps yourself, find out what K is. If K is negative 3/2, what do you do with that negative? You have to choose where to put the negative. You can't just let it hang out to the side. You don't put it, what if I put the negative both top and bottom? What's a negative over a negative? Is that right? No. So your negative either has to go in the top or the bottom. It doesn't matter which. Watch what happens. If I've got a negative 3 over 2, remember, this is your rise over your run. Remember how we have to look at it in 2 different directions? Change both signs. If I change this sign, I get a positive 3, and if I change that sign, I get a negative 2. Aren't they both a negative 3/2? Okay, so plot both directions. Start at 0 and start plotting. Negative 3 would be down 3. Positive 2 would be to the right 2. Or a positive 3 would be up 3. And a negative 2 would be to the left 2. So they should follow along the same line, which they do, And notice that your line is tilting in the negative direction. Make sure you add arrows to your lines. So how comfortable are you with that? Easy? You've done a lot of it in physics. How much of this have you done in physics?
All of it.
All of it? Okay. So this is nothing new. Is the terminology new? Constant variation. Have you talked about direct variation in physics? Okay. Well, you're going to get some physics problems in here. All right, so flip it. All right, so here's where the word problems come into play. So example 3, you are to assume that y varies directly as x. Where have you seen that before? On the other side. What did I say y varies directly as x is the same as? Y equals kx. The minute I see that, I'm going to translate that to y equals kx. Your job is to find k. So look at what you're given. Essentially you're given a full ordered pair. You're to use when y is 9, x is -3. Isn't that an ordered pair? All right. Don't I have an x and a y in here? I'm going to use this in step 1 down here. So step 1 says write a direct variation equation that relates x and y. And so your job is essentially to find k. So you might want to put here, you need to find k. So the first thing that you do, step 1, well, step A in 1, let's call it that. We're going to start out with y equals kx. That's our formula. Then you're going to plug in these values. So they gave you an x and a y. So part B, replace your y with what? What did they tell you y was up here? 9. So y gets replaced with 9. And x, after you substitution parentheses, it gets replaced with what? -3. How do you solve that equation for k? Yeah, divide both sides by not a 3 but a -3. And so then part C is I now know that k is equal to what? Because those cancel. Not 3 but, yep, -3. So it says, the directions say to write a direct variation equation. Is this a direct variation equation? No, but now you have the ability to write it. So this is your very first time in writing a true equation on your own. So we're going to rewrite the y equals kx, but we're going to replace k with what we now know it is, -3. So y equals, we're not going to use the 9 anymore. We used it to find k, throw it away, it's no good anymore. -3 x. This is what we were after. If I don't see this work right here, and be very careful, if you're asked to identify the constant variation and you skip telling me that k is equal to -3, then you'll miss points for that. So just read your directions, make sure that you're answering everything that you need to. Yes?
Why did you say y equals 15?
Well, we'll get to that in just a minute. So here's the purpose of this. When you look at the form or the lines down below, how many points are on these lines? How many points? More than 5. They go infinitely, right? Is there an infinite number of points on this line? There's an infinite number of relations of x and y, aren't there? Okay. What you have done right here is you have now discovered the equation to the line that relates when x is -3 and y is 9. I want to be able to use that same relationship anytime I have a value for x or for y. So if I tell you, and look what I do down here, so now I use the equation that you just found up here to find x. So now we're going to find x when they give us y. So isn't that a partial order pair? We're missing x. But we now know what k is. So we're going to use the equation we found here, y equals -3x. what's the word I'm looking for? Not developed. Why can't I think today? That's what we get for homecoming day. We found this in step 1. So that's where the y equals negative 3x comes from. It comes from this right here. So now anytime I give you an extra y, you ought to be able to find the other one. So how do we find x? What are you going to do? Plug it in. So we know that y is 15, so replace y with 15 equals negative 3x. The easy part is solving. The hard part is knowing how to do the process. So how do you solve for x? Yep, so that's the easy part, right? So then part C, what does x equal? Negative 5. So this is what they're looking for, find x. So example 4. If you can do it on your own, do it on your own. But again, we see this verbiage, y varies directly as x. The minute they use that phrase, you know we're dealing with y equals kx. This time, they give you a full order pair again, don't they? So follow the exact same steps that we just did. Step A, y equals kx. That's your general formula. Step B, plug in your x and y. Y is 9. But this time, x is positive 15. How do you solve for k? Just divide by 15. 15 doesn't go in there nice and evenly, does it? So what does k equal? Reduce that fraction. Don't give me a decimal. 3/5, because 3 goes into both of those, right? 3 goes into 9 3 times and into 15 5 times. So that's your constant variation. So they asked us to write a direct variation equation. This is not the equation, so you have to go one more step, rewrite this. Y equals, instead of k, we're replacing it with 3/5 x. Now, if they ask me for x or y, I can plug it in and find the other one. What are they looking for this time? Yep, I'm finding y this time, right? This one's, it's easier to find y than it is x. So step A, use the formula that we just found. Y equals 3/5 x. Plug into it. I don't know why.
Can you divide it if you please?
I reduced. What goes into both 9 and 15? 3. So 9 divided by 3 is 3. And 15 divided by 3 is 5. When I replace x, because the 3/5 is a fraction, I want to make sure that I write 40 as 40 over 1. Why would I want to do that? So I can do my cross canceling. Does 5 go into 40? How many times? 8 times. And then what's 3 times 8? So then y is equal to 24. When x is 40, y will be 24. So those aren't actual word problems. Now we're going to take that direct variation phrase and actually apply it to real word problems. So the very last thing that we're going to do is look at this word problem down here. So the number of words typed varies directly. So now we don't have y varies directly as x, do we? But I do see that phrase varies directly. What comes before varies directly? So isn't the number of words typed y? So in my let statement down here, I'm going to let y equal the number of words typed. What comes after varies directly? Yeah, so this part right here, the time spent typing represents our x. So now you know what to put where. So you're going to let x equal the time spent typing. And remember, since they use something varies directly as something, you should start with y equals kx. Or in this case, you want to use words, number of words typed, equals k, that constant of variation, times our x is time spent typing. Y is our number of words typed. X is our time spent typing. So the question says, if a typist can type 275 words in 5 minutes. So what's the 275 words represent? Is it an X or a Y? Number of words typed is Y. So this is our Y right here, isn't it? In 5 minutes. What is that? That's your X. Haven't they given you a full ordered pair? Isn't this like step 1 above in example 3 and 4? Right? Oh, shouldn't that say example 5 then? Oopsies, oopsie, oopsies. This is example 5. And I'm the one that typed this one up. Alright, so what I'm going to do is plug in that full order pair because I have to find the constant of variation just like we did above. It's the same step. So here's our step 1. Just like above. So plug in 275 equals k times 5. How do you solve? Question?
After the first time you saw, you just divide those each side by 5.
Okay.
But then that means that the k is 55, so...
Alright, so k is equal to 5 goes into 27 how many times? 5 times. What's left over? Out of 27 minus 25? 2. So I'm going to put a little 2 here. How many times does 5 go into 25? 5 times. So k is 55, right? So I have to write an equation before I can actually answer the question, how long will it take the typist to type a 935 word essay? Because you're not allowed to do scratch work and try to figure it out by doing a little bit here and a little bit there. So then step 2, I'm going to take that k equals 55, raise this up, and I'm going to write my direct variation equation. So y is equal to the 55 times x. And so this 55 went right down there, just like we did in the previous 2 examples, but this just happens to be a word problem. So now when they said, how long will it take the typist to type a 935 word essay, where does the 935 go? Does it go in for y or for x? So this is this would be like having y sub 1 and x sub 1. This is now my y sub 2. It's my second point, but I only have a partial point. So I'm going to plug that in. 935 is equal to 55x. How do you solve? Divide by 55. Alright, so you might have to do some long division over here off to the side. 935 divided by 55. How much does 55 go into 93? Once. So minus 55. How about how many times do you think 55 goes into 385? Yeah, because, 55 is going to go into 100 almost twice, right? You got 300 here, so that would be over 6 times, right? And then the 85, 7. Did you say 7 or 6?
7.
Let's try 7. What's 55 times 7?
35.
Oh, imagine that. So 7 times 5 is 35. 7 times 3 is 21 plus 3. Or 7 times 5 is 35. I can multiply. Plus 3, 38. So we don't have any remainder. What does the 17 represent? Because remember, it's a word problem. Yeah, but what is x?
Minutes.
So if x is 17 and it's time spent typing, and they set up here minutes already, right? So you might wanted to add here that this is minutes, just so that you don't forget. And so this is minutes here. So what's your therefore statement gonna say?
Therefore, it will take
Therefore, it will take the typist, because we're gonna rewrite that question as an answer, 17 minutes to type a 935 word essay. Do you have to say the whole thing? Yes. You can't just say, therefore it will take him 17 minutes. My question will be to do what? So this is the hardest thing on your homework, is to take what you learned above, the direct variation equation, and apply it to a word problem. But remember, it's no different. So we've laid out the steps here. Make sure you have your notes with you when you're working on your homework. Okay? If you're doing your homework without your notes and you're struggling, that's an issue. So get out those notes, re-listen to this video. I'll get you guys your homework.